Good afternoon, everybody. Thanks for choosing this track and choosing to attend this talk. Today we'll be talking about micro-interactions and we'll be elevating the user experience using Framer Motion. Before we get into the talk, a little bit about me. I'm a senior full-stack engineer. I work for a company called Omeo. We are these travel aggregators. I work in the platform teams, like UI platform and backend platforms. I blog once in a while and make some videos once in a while. I love to teach, travel, and eat, try all different food. And trust me, that's me in the photo, just without the beard and the mustache. So that's my ID. Awesome. So let's get started. Today's agenda. First, we'll talk what micro-interactions are and their structures, like a bit of theory. Sorry, I can't avoid it. And after the theory, we'll get into what Framer Motion is and what are the APIs it offers. Not everything, but just the top ones, and how to use it and few code samples. Then whatever we learned in the theory and in the API, we'll just use it on few demo and then create a UX. And finally, just some disadvantages and where not to use it, and we'll have a QA session. That's it. What is micro-interaction? Before getting on to the theoretical concept of micro-interaction, let me tell you a practical concept of micro-interaction. So the best example of micro-interaction is me being scammed by my taxi driver in the morning. So what he did, as soon as he met me, he said namaste. He had good conversation. The things were very nice. When I got into the taxi, he was continuously having conversations, keeping me engaged, and took a very long route. For 1.3 kilometers distance, he took on a long route, and he brought me after like 20 minutes, 25 minutes. So that is the power of micro-interactions, not the scamming part, but the other part, where we interact with users, we give feedbacks, and then we keep them hooked to our product. Okay, so now coming to the theoretical concept of micro-interaction. Micro-interactions are small, subtle design things, design concepts in the UX, which lets the user hook to our products. It just enhances the user experience and makes things so good for the user. I'm sure many of you would have noticed this, like when you pay, there will be like small animations on the payment cards, and it feels nice. Actually, we are losing money. We shouldn't feel nice, but the animation makes us feel nice when we pay, right? That's the power of micro-interactions. Okay, coming to life cycle of micro-interactions. Micro-interactions, almost all micro-interactions fall under this 4 life cycle methods. First thing is trigger. Trigger is the place where the micro-interaction starts. It's a place or an action or anything that triggers a micro-interaction is the trigger. And then rules. After the trigger, we check whether the trigger is a valid trigger or not a valid trigger to trigger the to start the micro-interaction. So those comes under rules. Then the feedback. So when the trigger is fine and when the rules are just in place and right, then we start executing the micro-interaction. And what does this micro-interaction gives? It gives some feedback to the users, right? And finally, loops and modes. So it can either continue doing the same thing infinitely and loop into it, or get into another mode. We'll see more about this with a small example. So if you see, this is just a very minute or a very small micro-interaction when a new notification comes in. So what is the trigger of this particular micro-interaction? Trigger can be something like a backend call, an API call, or a button press. So that might trigger a new notification. And rules, we will check if it's really a new notification or if it's just the existing notification. If it's existing notification, we just ignore it. If it's a new notification, then we choose to show feedback to the user. And what is the feedback? The bell moving, without the sound, of course, and then the dot. That's the feedback we give to the users. And here, though this is a GIF which is animating in loop, technically we don't do it in loop, but it goes to a mode. That is, before the micro-interaction, it was in a no new notification mode. And after the micro-interaction, it gets a new notification. So it's in a new notification mode. These are the 2 modes before and after, and this is how it travels from the previous mode to the next mode. Next, roles in UX. Yes, we know what is microinteraction now and how it can be broken into smaller life cycles. But how does it help really in the user experience? First and foremost thing is feedback. It just tells user that something is happening. It doesn't leave them like clueless. It always keeps updating the user that, okay, this is happening, and the next thing is going to happen, something like that. So that's the first thing and the major thing about the impact of micro-interactions in user experience. Second thing is user engagement. I'm not sure how many of you remember this buffer in YouTube. Nowadays, internets are very fast, but back in days when it used to buffer a lot, they made it into a snake and ladder game. That kept us hooked until the video get loaded. Like usually before the snake and ladder game, if the video takes like some time, I just close it and do something productive. But then when after they introduced this, okay, I'll play this game until the video gets loaded, and it kept me engaged. That's the power of micro-interaction, and we can keep the user engaged. Next thing is enhancing usability. I'm not sure how many people book tickets through, so this is like a shameless plug, but how many of you book tickets through DB and official websites? Mostly you will have to repeat 2-3 times because there will be some failures, and most of the times you will not have more clear usability stuff. Whereas our company, Omeo, it's a travel aggregator. We do all those for you, and it gives you like a smooth experience. Next is like an emotional connection. Personally, for me, though there are many, so I live in Berlin, so there are many delivery apps, but I am personally connected to Volt. The major reason is micro-interactions they provide. When people are so comfortable in using your product, even if somebody is giving a bit cheaper, if it's very cheaper, obviously the user will move. But if it's a bit cheaper, people tend to stay with the product where they are connected to. And that mostly happens because like micro-interactions can boost the emotional connect for the product. And of course, branding. All of us know how Uber remade the maps, and they did a branding with the micro-interactions of moving the cars, and the whole world started copying. But still, we see Uber as the pioneer. And of course, mobile and responsiveness. Nowadays, everybody use the major traffic for most of the websites come through mobile. So adopting to it with some cute animations is like really nice. These are the roles in the UX of micro-interaction. Next, let's get into the library part. Framer Motion. Framer Motion is nothing but a motion library which was open sourced by Framer. Framer is like a no-code website builder, and they open sourced their motion library or the animation library for the people to use. It's simple to set up. Just install it through npm or yarn, and you can already start using it. So, how does this motion library works? In React, we have state variables, right? Like we use state as the major source of truth for our components. Similarly, for the animations in Framer Motion, we have something called motion values. You don't have to explicitly create those motion values. Framer does it for you. But the entire operation of Framer is based on this motion values. So it creates motion values for all the components which are imported from Framer. And then it actually keeps a tracks of the values and the velocity. So if, say, you have a starting point, and if the component is getting animated, it keeps track of all the current data and the speed the component is moving. And since it has both this thing, it uses basic math to calculate the next step of the animation. This way, it knows from where the animation starts and how it goes. And the beautiful thing about using Framer Motion is, this doesn't happen within React's render cycle. Since we don't use state variables, it doesn't happen within the render cycle, and that gives us like good performance of the animations. When the JavaScript is like heavy, when there's like serious computation, your animation is not like sluggy. The main reason is it is outside of render cycle and directly operates on the DOM. This is how Framer works internally. Let's move forward with the Framer Motion APIs. every API, or generally the concept of framer animation, it has three things. One is the initial state or the starting point of the animation. Two, the target state or the ending point of the animation. And three, transition, how you want to start and end, like the duration or anything related to that. So these are the major parts of animation, and we'll be following these three principles on all the examples and the live codes. The first and the most powerful or the most commonly used API is Motion API. So it comes as a component from where you can extract divs or paragraphs or H1 elements. Technically, it has most of your HTML components inbuilt. So how do we, let's start with an example. Imagine we have a simple H1 element with text, welcome to Frontmania. And first step to animate this is, we need to convert this particular H1 element into motion element. And how do we do that? Just add motion.h1. We need to, of course, import motion from Framer Motion. It's not an inbuilt component, but just adding motion dot to most of your elements will convert it from a normal HTML element into a Framer Motion element. Now, once we do this conversion, we get all the power of Framer Motion to animate it. So let's go and animate it. Like I said, we have three stages, right? Like initial stage, target stage, and then transition. We'll not look into transition for now, but we'll see initial and target stage. With the name suggest, initial is my initial state on how my component have to look when the application is loading. And animate is the final state of the animation. So now I'm saying initially keep my opacity 0, and that my target opacity is 1, which I'm passing to animate. You can see how it gets animated. It just flicks. Why is it flicking? Because I did not tell Framer how to animate it. I just said start with 0 opacity and finish it in opacity 1. And that's why there's a flicker. However, let's go to the third stage on how the animation should happen. That's the transition prop. In transition, you can give so many things. Here I chose to give only the duration. Now it's not flickering anymore. I gave the duration as 2 seconds, so it's like slowly starting from opacity 0 and moving to opacity 1 in a time frame of 2 seconds. As basic as this, and this is going to be the base of your entire animations. Initial, animate, transition. Start, end, how. This is the basic of Motion API. Next thing is keyframes. Like our CSS, we can have multiple breakpoints in our animations, which is called keyframes. And it's very simple to do it in Framer Motion. Just taking the same text, same component, with the same duration, just that I'm going to add multiple level of scale. I'm starting with 0.8, then I'm going to 1, then 1.2, then 0.9. So I have given some random numbers. And if you see, the text is just like gets bigger and smaller, and it just looks like it's getting like a heartbeat. And the entire animation happens in 2 seconds. So what Framer does, it goes into the array, picks up every value, and applies those animation on the component one by one in the order you give within the time frame you specify. This can be used with, like, you can use multiple like scale, opacity. You can combine multiple attributes and then create even more complex animations with keyframes. Variants. This is one of the interesting part in using Framer Motion. Though we pass those, initially we were passing those animations like directly as objects, right? But it's easy for us to maintain it somewhere else and reuse it. So we can create variants. And this initial and final, the terms, they are not constant. You can give anything you want. It's more for our understanding that I have given like initial and final. However, why do we need this variant? Or what is the advantage of using variant? Once you apply a variant to one parent component, it just gets propagated to all the children. So say if you want to maintain dark mode, like an animated dark mode and light mode in your application, if you just maintain the modes or the variants in the topmost parent, it just propagates for all the children. This way you can easily maintain it's more about maintenance. This way you can easily maintain in what variant, how a particular component should look. Here if you see, I have two components. One is my H1 element, and inside which I have a span element. I want a different animation for my span element and a different animation for my H1 element. So I created an initial stage where opacity is 0 and opacity is 1 for my H1. And for my span, my opacity is 0. And in the final state, it gets 1. But also, I have increased the duration. So technically, my H1 element will appear in 2 seconds, and my span element will appear in 5 seconds. However, these two elements will always be in sync because I am not passing the values directly, but I am passing the variance. And when it's initial in H1, it will be initial in span as well. And when it's final in H1, it will be final in span as well. Let's see how this works in the world. So if you see, my welcome to just appears in 2 seconds, whereas Frontmania takes like 5 seconds to fully appear. This way, I'm having same variants, but different animations for different components, and controlling it globally at one place. Next thing is animate presence. Until now, we have seen only components coming into the DOM, right? Like we move components into it, we add opacity or move the positions. But then we have something called animate presence. What it does, in React, we don't have a lifecycle method which tells you whether a component has gone out. And animate presence does that for you. So you can add exit animations to your component very easily. Without this handling exit animations in React is a pain, right? Like you need to still hold the value, hold the state, make an animation, and then manually flush it out. Whereas with animate presence, it's like a piece of cake. So let's see how we can use animate presence with a simple example. Here I'm having a to-do list where I'm just iterating through an array of objects and creating a to-do. And if you see, when I add a to-do, it just appears blindly or blankly. There's a list and suddenly a new element pops in. However, we can add some animation to it. The initial and animate is the same thing we discussed. When something gets added, it's just going to slide in, like the new one. However, there is a new thing called exit. This exit will work only when your component is wrapped within animate presence. That's why I'm wrapping my entire list within animate present, and I'm adding exit animation. So what basically happens is, when the animation starts, the component is in like minus 100 x-axis and opacity 0, and slowly it comes in with opacity 1 and to x-axis 0. And when I click on it, it just goes off the screen, that is exiting. And what happens there, it starts from 0 and goes to 100, and gradually decreasing its opacity. This way, we can have cool exit animations with not so much trouble. If you have to remake the same thing directly in React without using Framer, then it's going to cost you a lot of code and time and thinking as well. And you might also have some side effects. But this works seamlessly because this works outside React's render cycle and directly on the DOM. Next thing is gestures. So that's with the exit animation. Next thing is gestures. Framer Motion supports the common gestures like hover, drag, tap, and pan. So all these gestures have lifecycle methods like on drag start, on drag end, while drag, while hover, similarly. And a small example, we will just reuse the same to-do list, and we will use something called while hover. And what this while hover does, when I hover on it, it gets activated, and it scales the corresponding component to 1.2x. So when I move my mouse pointer on the component, it just zoom in. And while hover happens only when the hover is on. You have other methods like on hover start and on hover end as well. You can customize it and use it for your own needs. This is a cool API which can come handy when you are using drag and drop based animations. Generally, drag and drop is like bit hard to handle in your applications, but Framer Motion gives you a component called reorder. So basically what you do, you pass all your items, the list of items to reorder, and also this function which can change the items. So I have my to-dos and set to-do is from my use state of React. So I'm just passing it to values, and on reorder, I'm going to call set to-dos. And in my item, I'm just going to pass my to-do as value and then key. And whenever I move a component, it automatically reorders it, not just in the UI, but also in your state. This way you can it's not just animation, but it also changes your original data and reorders it based on your drag and drop. This way a lot of complexity is handled out of the box by reorder component. Next thing is layout animation. Until now, we saw individual animations being, individual components being animated. But we have, we sometimes have need for animating the entire layout, right? Like say we remove one object, we want the entire layout to just readjust itself and fill in the space. But this is very easy to do with Framer Motion. All you need to do is, there are two things. One, the layout prop, which tells Framer Motion that this particular div might change its layout. And whenever there is a layout change, just animate the layout change. Just don't apply it blankly. And the other one is layout group. So say, for example, I have 3 divs, right? Say there is a layout change in my second div. Only my second div will know that there is a layout change. And the other 2 divs will be dumb, and they will just stay wherever they are. To communicate that there has been a layout change in another div, so you adjust yourself also, we use this layout group. I'll not show you a GIF for this, but we'll do a small live demo on this. And we also have some useful hooks. Until now, whatever we spoke, it's like declarative way of coding, but you can also use imperative way of coding using these hooks. So use scroll gives you the position of the scroll, like how much the user has scrolled. Use motion value. Like I said, Framer Motion works based on motion values. And use motion values let you control it and get its value at any point of time. Use animate. Instead of using the animate prop in your motion component, you can use animate to dynamically or programmatically trigger an animation. We'll see how we will use scroll and use animate and all those things. But the other 4, use spring. Spring is like enabling spring animation for your components, but I'll not touch those things. Use will change. Use will change is equivalent to your CSS property will change. So in CSS, when you pass the CSS attribute will change, the CSS compiler will know that this particular element is going to undergo change, so I'll be ready for it. And it improves performance. It's just the equivalent thing in Framer Motion. Use drag control. Like we see in reorder, it's automatically handled, but if you want, you can control your drag controls programmatically as well. Use in-view. It is more equivalent to the intersection observer. So this tells whether a component is within the viewport or not, as simple as that. Yep, enough of talking and seeing code. Now we'll type some code. Okay, before I type some code, I can show you whatever you saw in GIF. This is the motion. This is the keyframe. In GIF, it looked a bit laggy, but here it's like so smooth. And this is the variance. Oh, sorry, I clicked something else. So this is the animate presence. I add a new one. It just slides in. I click on something. It just slides out. And gesture, the same thing, but on hover, it just zooms in. Reorder, just simple as that. Awesome. So this is with the demos part. Now let's get into code. Let's start with a basic example. Is the screen visible or should I zoom in? People at back? Is it good? All right. So yeah, just don't look at my dirty code, but let me show you what component it is. So this is my usual counter example, which you would have seen like 1,000 times. When I click on plus, it just increases my count, nothing new in it. However, it's just so plain, right? I click on it and just the number changes. What if we add some animation to it? First step, we change it to motion.p. So now we have converted our HTML component into a motion component. Next, we'll start adding animation. What do I want my initial state to be? Now I want my number to come from bottom to up and fade in. So my initial state will be, my Y position will be like 100 pixels down, and opacity will be 0. And let me add the final thing, which is like Y will be 0, and opacity will be 1. And I'll add a transition, duration of maybe 0.3 seconds, because too long might not look good. And now I'll refresh this. If you see, you saw 0 coming up, right? Like now when you press the counter, it's animating. And I feel like increasing a number from the bottom is more interactive for the user than just seeing a plain number changing. This is some basic animation. Next step, we'll go to the, I'll show you the component first. So I have 3 currency component, and on hover, I'm just showing the full expanded values. So INR becomes Indian rupees, USD become US dollars, and EUR becomes euro. So not very big. However, the point here is, it's so laggy. You see that, right? It's just moving the components in a hard way that it's not so smooth. How do we fix it? We are going to use layout. Where is it? Thanks, yeah. So basically, I have a component which on hover changes the value. Like is hovering true, it shows hovered text or unhovered text. And I'm passing hovered and unhovered text here. And already there is like some basic animations. And to make it smoother, all I need to do is pass the layout prop and save it. Go there, refresh. Now watch closely. It's smoothly expanding. So now there is one more problem. Yes, though the cards smoothly expand, now only that card knows that there is going to be a layout animation, because we added layout only to the particular div. And when we hover on it, the animation is smooth, the layout animation is good. But say when I hover on USD, INR and Euro doesn't know USD value increased. So they just stay wherever they are. But accordingly, they should also change, right? They should also know that their layout has changed, and they should also adjust themselves. And to do that, just 2 more lines of code. Encapsulate this thing in layout group. Save it, refresh it. Now look at it. When I hover on it, everything adjusts itself in a smooth way. It's not flickery anymore. And all we did is add 3 lines of code to have this animation so smooth. That's the power of Framer Motion's layout animation. Next thing is, so maybe I'll zoom in a bit. Yeah. So I have like just 5 numbers, and when I click on something, it just gets selected. Okay, nice, but it's so blunt again. And going into the code, all I did is I have an array. I iterate through the array. I create a motion component. And on top of the motion component, I have a div element which forms my circle, the red circle. And that is present only on the selected item. So when I click on something, that item gets selected and the circle gets formed around it. And how do I animate it? All I need to do is add something called layout ID and maybe like outline. Save it. Now refresh it. Look carefully. Now it's animating. So what is really happening here? This layout ID works in a unique way. When there are multiple components, and say initially the layout ID, since one is selected, now the layout ID is present only on the component 1. But when I select the component 3, the layout ID moves from component 1 to 3, and not just the layout ID, but also the entire component in a layout animated way. This way, it's super simple to implement this complex, otherwise would be complex animations. That's with the layout ID. And last thing, okay, first I'll show you the demo. So imagine he said, one day you leave this world behind, so kind of song, but but then I don't know where I left the word, right? Like I'm not exactly sure where, I just saw you people and I forgot until which word I sang. So let's make this bit interactive. It's simple component which just scrolls itself. First step, as usual, we will make our components into motion. So first step, we converted it into motion. But right now, we are not going to use any traditional way of animate or initial and all those things. We are going to use this imperative way of coding and going to use useScroll. So for me, I want to display the words, like the lyrics word by word, as the page scrolls. So that way I know until when what I have seen. First thing is to get the scroll position. So I'll use the hook which I showed sometime back, useScroll. And I'm interested only in the Y position. So I'll get my Y position. Second thing, you remember useAnimate? I want to, of course, animate it, right? So I'll use useAnimate. And it gives me two things. Scope, that is on which component this animation should work, and animate. Now, I'll apply the scope to motion.p using ref. Next, I'll create an empty variable, previous shown word. So until now, whatever word I showed, I will have a count on it. So that's 0. Now we will use motion value event. So what is this? We saw earlier that motion values are the driving forces of Framer, right? So whenever there is a motion value that changes, use motion value event gets executed. And what value we need to look out for? We need to look out for scroll Y progress. And on the value, what should happen? A change should happen. Whenever that value changes, this callback will get executed. And inside the callback, what am I going to do? I'm going to calculate something called show until. That is, okay, the page has scrolled, it has come to a certain position. Now I need to decide until which word I should show, right? So show until math.floor of latest, that is my latest scroll value, into words array.length. This way, now I have two things. One, previous shown word. Second, show until. Now I'll have an early return if show until greater than words array.length. That is, if we crossed already, then don't do anything, return. But if it haven't crossed, while previous shown word lesser than show until previous shown word plus plus. But now we will do the animating part. What are we going to animate? Scope.current is nothing but my P element, the paragraph element. However, I'm not going to animate my paragraph. I'm going to animate my span because that's where my words reside. So what I'll do, I'll just use children. Let me know if I make any typo. I'm good at it. And what is the children it should show? It should show my previous shown word. And now we'll do the animation part. Opacity, and I'll make it 1, and I'll make the opacity 0 here. I think it should work. I'll refresh. Now it's good. He said, one day you will leave this world behind. Now I know where I left it. All right, so that's with the demo part. Cool. So when not to use microinteractions? We have spoken all the positive things about microinteractions, but when not to use it? So people sometimes access or enable reduced motion in their mobiles, right? So when that is enabled, your animations are not smooth. It will be staggering. And you can detect it using a hook called use reduced motion, which tells you whether reduced motion is enabled or not in the particular device, and adjust your animations and microinteractions accordingly. Second, accessibility. Not every place microinteractions are great when it comes to accessibility. Of course, you can handle it, but you need to be very aware of what you're doing. Next thing is data and battery use, because it's some code which is infinitely running. So if you don't plan it properly, it can just get out of hands. And the last thing is overuse. At least I do it a lot, because it's so nice to see such things, and I start doing it in the application, so just don't do it. Expert advice. Also, with performance, there is one catch to it. Most of the things we saw work on GPU. Like whatever is supported in GPU, transform, opacity, cliff path, filter, and background color. When you use such properties and animate using framer motion, it works on GPU and the performance is like super good. But say, you have on update on motion component, or if you start using the motion values inside styles instead of animate or initial, or if you use repeat delay, or these things comes under transition. Repeat type mirror, and damping is 0, which is like which comes under spring animations. Under these conditions, the GPU is just being ditched, and then it starts using CPU using JavaScript. It becomes JavaScript-based animations, not GPU or CSS-based animations anymore. So you need to be careful when you're choosing your things. That's it. Thank you for being a wonderful audience and listening.